in your PMI chapter, Principle of Mathematical Inductions. Students, today I am going to same concept related our step 1 and in step 2. Yes, our question number 5th one, 4.1 exercise, 1 into 3, 2 into 3 square up to level to fit that 2n minus 1, 3 raised to n plus 1 plus 3 by 4. So students, same applications here. One of the step 1, if n is equal to 1. So what is the LHS? Our LHS is this. It is the 3. And what is the RHS? Yes, RHS is that one. 2n minus 1, 3 raised to n plus 1 plus 3 by 4. Putting down, in place of n is 1. It's very easy process. Check. Here 2 minus 1 is 1. 3 raised to 2, 9. 12 by 4, which is how many? 3. LHS and RHS same. So I just write down LHS equal to RHS. So what is the E1 is true. And step 2. I hope you students enjoy these chapters. It's very easy. Step 2. What is the step 2? If pk is true. And my pk is done. This p of n, I translate in the k. 1 into 3, 2 into 3 square, 3 into 3 cube. Here k into 3 raised to k, and is equal to same. 2k minus 1, 3 raised to k plus 1 plus 3 by 4. Now, students, I am moving ahead. Step 3, which is to prove. What will prove? Yes, in place of k. Students, I show out that k plus 1. So 1 into 3, 2 into 3 square, 3 into 3 cube, dot 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 dot. Here, just change k plus 1, 3 raised to k plus 1. Here, 2 with k plus 1 minus 1 and k raised to k plus 2. Why? Because in place of k, I write down k plus 1. And here now I start easily LCM for LHS. Students, what is the LHS now? 1 into 3. Here I write down, don't worry. 1 into 3. 2 into 3 square, 3 into 3 cube, and here k plus 1 with 3 raised to k plus 1. And think about to one back step value. So 1 into 3, 2 into 3 square, 3 into 3 cube, and what is the one back step? Yes, which is k, 3 raised to 3. And here same is. Now look at that, this value. That is your step 2. Yes, up to k, 3k raised to k is known value. I just apply that 2k minus 1, 3 raised to k plus 1 plus 3 by 4. And last term is as it is. K plus 1, 3 raised to k plus 1. And mention it is pk is true. And here students, it's easily now further take LCM. So 2k minus 1, 3 raised to k plus 1 plus 3. This 4 multiplied by upper side. 4 with the k plus 1 by 4. Now students, this 3, actually that's your RHS term. And I only common take here and here. Only k plus 1 with 3 the power. So, you just common taking 3 raised to k plus 1 power. What is the remaining? 2k minus 1. 4k plus 4. And this 3 is as this. By 4. Actually, your numerical is done here. It is 6k plus 3 plus 3 by 4. And you students checking here common with the 6k plus 3. How much common? Yes, which is 3 only. And remaining are surely you convert your answer in the RHS term. So I just only write down 3 raised to k plus 1. Here common 3. What's the remaining? 2k plus 1 plus 3 and by 4 same. Students, you know generally base same. Then power addition. So here addition also 3 raised to k plus 2. 2k plus 1 plus 3 by 4. Check. That's your RHS. This RHS. This how much? 2k plus 2 minus 1. It is 2k plus 1. Yes, other is same as. So that's why I write down P of k plus 1 is true. It means what? If Pk is true, then P of k plus 1 is true. That's why I tell in the last line. Therefore, by P and I, Pn is true for every n belongs to natural number. And here students, our this question is also happily done. Yes, I hope you understood that type questions. Now I am going ahead to question number, continue in the sixth one. So sixth also students very easy and simple questions in same pattern numericals. So my question is that prove that by PMI Pn which is given 1 into 2 plus 2 into 3 plus 3 into 4 plus n to n plus 1 and proving data n plus 1 n plus 2 by 3. Same expression students. Similarly, I am going to by 2 steps. One of the step 1. If n is equal to 1. So what is the LHS? 1 into 2. It is totally 2. And RHS, that's your RHS. Yes, apply the data. N into n plus 1, n plus 2 by 3. And that is 1, 2, 3 by 3. Check. The both are same. Yes, LHS equal to RHS are same. That's why I change. My this step is done. So P1 is true. That's the final. Now step 2. What is step 2? If Pk is true. So apply our given term P of n converting into P of k. Yes students, I am going to slowly. Here k apply 1 into 2, 2 into 3 plus 3 into 4 plus here k with the k plus 1 and is equal to k plus 1, k plus 2 by 3. That's our RHS. Now I am going to next step 3, which is known to prove. That's your to proving what? P of k plus 1. Very easy. 1 into 2, 2 into 3, 3 into 4 plus here k place. We write down k plus 1. So that is the k plus 1. This change only. Here also k plus 2 and is equal to how much? K plus 1, k plus 2, k plus 3. Only one ahead numbers apply. And now I start my LHS, which is 1 into 2, 1 back step. And back step is a 1 into 2, 2 into 3, 3 into 4. Yes. Here only one less term. K plus 1. And here same as. Now students, this value up to that is both are. You know very well. It is 1 into 2 to k plus 1. This full value already I know, and that side put in there. So my value is k with k plus 1 with k plus 2 by 3, and this data same as k plus 1, k plus 2 by 1 because pk is true. And here students, I just apply again repeat this part is your step 2. Every time you show with that pk is true. Now easy, LCM check. Either common take. X k plus 1, k plus 2 common. What is the remaining? K by 3 plus 1. It's very simple. K plus 3 by 3. LCM no 3. Check. That is your RHS. Yes, definitely. So I just write down it is your RHS. So what you prove? P of k plus 1 is true. That's it. Proving the target. To prove over. So last write down if pk is true, then what do you prove? P of k plus 1 is also true. Therefore, by PMI, principle of mathematical induction, Pm is true for every natural number. Here students, our rule wise, this question number 6 also happily done. I hope students you enjoyed this part very well and very easily. I am going to explanations here. Now continue. Question 6. Yes, 6 also. After that, sorry, not 6. 5th and 6th over. Now I am going to 7. Same pattern. P of n. 7th one. 1 into 3. 3 into 5. 5 into 7 plus 2n minus 1 into 2n plus 1. And which is true n into 4n square 6n minus 1 by 3. Yes students, here also same explanations and rule wise is same doing right. So first of all I start our step 1. Yes students, that is step 1. If n is equal to 1, so what is the first LHS? This step first. 1 into 3. And RHS we have to n into 4n square 6n minus 1 by 3. Here apply your value for n is equal to 1 only. So I just get it here 1, 4, 6 by 3. 6 and 14 minus 9 by 3, which is 3. So conformably I am saying LHS is equal to what? RHS. So P1 is true. Now step 2. What is step 2? If PK is true, that's all necessary. You write down every time your step to step. And this whole n, Pn, translate into terms of pk. So only n place I write down p of k, which is 1 into 3, 3 into 5, 5 into 7, plus here 2 into k minus 1, k plus 1 is equal to k with 4k square 6k minus 1 by 3. Yes students, now I am moving ahead slowly. Step 3, which is to prove p of k plus 1. Same way, k translating k plus 1. So 1 into 3, 3 into 5, 5 into 7 plus here 2 with k plus 1 minus 1. Here same 2 of k plus 1 plus 1. Look at that, only k translate into k plus 1 and is equal to k plus 1. This is a very big solution now. 4k plus 1 whole square 6k plus 1 minus 1 by 3. That is a very big expansion. Don't worry, I am going to slowly add edges. 1 into 3, 3 into 5, 5 into 7. Here look at that. 2 with k plus 1 minus 1. Same, look at that. 2 of k plus 1 plus 1. Now you again multiply. These are one back term of these total values. So what you get? 1 into 3, 3 into 5, 5 into 7. Students, here what next steps? Which is 2k minus 1, which is 2k plus 1, and this same is related. 2k plus 1 minus 1 and 2k plus 1 plus 1. Now again this part up to that, these all are just I highlight by this total value students. Which is your step 2? Look at that. And that value I putting down there this one in place of here. So I just getting how much in place of that? K with 4k square 6k minus 1 by 3, and this same is how much? 2 with k plus 1 minus 1 into 2k plus 1 plus 1. So finally now you translate into simplest form till up to that's the RHS. So k 4k square 6k minus 1 by 3, and here how many? 2k plus 2 minus 1. I mean 2k plus 1. Here 2k plus 3, and now we are checking LCM process. Yes students, after that I checking to LCM. This is multiply 4k cube 6k square minus k. This is multiply. And 3 LCM multiply outside. This multiplications 4k square 3 to the 6k plus 2k plus 3, and downwards 3 same is. Now after that students, I just simplify by here because that is a short space. Now these calculations, further explanations, after checking your multiplying and LCM 3, sure your answer is this. Look at that. Other steps are here right now. So 4k cube 6k square minus k plus 3. Here how much? Yes, 4k square 6 into 8k plus 3 by 3. So 4k cube 6k square minus k, here 12k square, 8 is a 24, 12 is a 9. And now students, here just I rearrange our power divided value. 4k cube 18k square 23k plus 9 by 3. And these are now simplified by k plus 1 splitting. But it's a very big process. I just direct write down this answer. Don't worry students, you also write down in exam. It's a prove that step, that's why. I just show you the direct. K plus 1, 6 of k plus 1 minus 1 by 3. Actually these are expansion if you majority of these two steps are same. So that's the RHS. Yes. So P of k plus 1 is true. Last write down same solution by the last steps. Similarly, you can show down that is if Pk is true, then P of k plus 1 is also true. And here students, I am just showing out that by PMI. Pn is true for every n belongs to, yes, for every n belongs to natural number. Here students, I again repeat you think about why is written in a direct answer. Don't worry, you RHS no, that's why I written. Otherwise, you making the splitting by after long factorization method and then after you create that. It's a very big process. Don't worry, write down that is same. Now students, I am moving ahead. Question number 8. Eight also same pattern. Prove that P of n, which is 1 into 2, 2 into 2 square, 3 into 2 raised to 3 plus n into 2 raised to n, and proving data n minus 1, 2 raised to n plus 1 plus 2, same to it. So I am going to slowly, don't worry. Step 1, if n is equal to 1, what is the LHS? 1 into 2. RHS, this RHS. Full limit. N minus 1, 2 raised to n plus 1. Putting your n plus 1, students is 0 plus 2. Yes, LHS is equal to RHS. So what you checking? P1 is true checking, and that's our first case is done. Now step 2. If Pk is true, students, I again revise for you. Rule necessary to write down. Step 2. Pk is true. Now what is the Pk? 1 into 2, 2 into 2 square, 3 into 2 cube plus k into 2 raised to k. And here same, k minus 1, 2 raised to k plus 1 and plus 2. Similarly, step 3. What is step 3? To prove P of k plus 1. Necessary write down. These all are the big theoretical questions. So P of k, 1 into 2, 2 into 2 square, 3 into 2 raised to 3 plus, here k changing k plus 1. So here k plus 1, 2 raised to k plus 1, and here also same, k plus 1 minus 1, k plus 2 power into 2. This cancels. And I start now our LHS. What is the LHS? 1 into 2, 2 into 2 square, 3 into 2 raised to 3 plus k plus 1 with 2 raised to k. So that here again think out to one more back step. Here what is the back step? Yes, that's the back step is you create your answer part. Very easy. 1 into same, 2 into 2 square same, 3 into 2 raised to 3 same. Now, students, here I just create one back term. K plus 1 is back term is a k, 2 raised to k, and this is the same as to answer is k plus 1 2 raised to k plus 1. And students, here your value I just write down 1 term. So this term and this term is equal to how much? Up to that 1 to 2 raised to k? Yes, that is known, which have to k minus 1 2 raised to k plus 1 plus 2. This full value is your step 2. And these are as it is. What is that? K plus 1 2 raised to k plus 1 and mention here because pk is true. Now students, look at that. This 2 raised to k plus 1 2 raised to k plus 1, that's your answer part. I just common take here and here. So what you getting? 2 raised to k plus 1 common, remaining are k minus 1 k plus 1 and these two students I just show out same as. So finally 1 and 1 common. I have only 2 raised to k plus 1 into how much? K plus k 2k. And again base same power addition. So 2 raised to k plus 1 plus 1 into k. You have to 2 raised to k plus 2 k and plus 2. Check. That's your RHS. Here k 2 raised to k plus 2 plus 2. Yes, it is your RHS. So I just write down p of k plus 1 is true. Therefore, if pk is true, then p of k plus 1 is true. So finally I write down by PMI. Yes, by PMI, Pn is true for every n belongs to natural number. And here students, for these 8 questions is happily done. Yes students, I think you now properly understood what we write down in these 3 steps. Correct, no? Yes. Now I am moving ahead. Next question, 9th one. Question number 9. Prove that by PMI rule, P of n, which is 1 by 2, 1 by 4, 1 by 8 and 1 by 2 raised to n, 1 minus 1 by 2 raised to n. Yes students, here this part is also very easily. I just finished them in the parts of PMI. These are proved. Now I go into that one. Same as, but this is the IMP question, students. So what is the step 1? If n is equal to 1. So my LHS is 1 by 2. Students, if you n equal to 1, then you taking first step. And what is the RHS? This RHS 1 minus 1 by 2 raised to n. 1 minus 1 by 2 raised to 1, which is how many? Half. So LHS is equal to RHS. It means P1 is true. Now students, your first step happily done. Now going to step 2. What is step 2? If Pk is true. So what is the P of k? This whole equation again I write down in the terms of k. Yes students, k belongs to natural number. So I go in now step 3, which is to prove. What is the step 3? P of k plus 1. I just show out in place of k plus 1. So half, 1 by 4, 1 by 8. Here 1 by 2 raised to k plus 1. Here also same. 1 minus 1 by 2 raised to k plus 1. And here k belongs to n. I prove by LHS equal to RHS. And same calculations. Now I start from our left hand side. Students, this is an easy sum, but I am doing. So, what is your LHS? Our LHS is this one. Only I just putting down there half, 1 by 4, 1 by 8, and 1 by 2 raised to k plus 1. And here again I asking what is the one back term, one previous steps. So definitely you know half, 1 by 4, 1 by 8. Here are one back step, 2 raised to k, and which is same, 2 raised to k plus 1. If you again one back term return, then 2 raised to k minus 1. Now students, look at that, this and that are totally your step 12. Correct? That will be apply here. 1 minus 1 by 2 raised to k this one. And last one is same. Because I return pk is true. Students, here you mention. Now I think your RHS is done. Check. Can we write down base same then power addition? And if you power additions, then both base same. Here you took out the common. What is the common? Yes, 2 raised to k common. 1 minus half remaining. And how many 1 minus half? Yes, which is half. Now again base same, power addition. So we write down here 2 raised to k plus 1. That's my RHS. Check. Why write k plus 1? Base same, power addition in these both terms. 1 by 2n, 1 by 2 raised to k. So I just write down, therefore p of k plus 1 is true. So if p of pk is true, then p of k plus 1 is also true. Here students, our fast and easy last ending. So by PMI, Pn is true. Pn is true for every m belongs to natural number. And students, here our 9 questions is happily done here. Yes students, now 10 questions you try just itself for practice only. Don't worry, I explain you in the next part. But you try today homework part for question number 10. And illustration also in the 1 and 2. Only 2 illustration. Sorry, not 1 and 3. 1 and 2. 1 and 3 you take. 1 and 3. Okay? Yes students, up to that in this part I completed for PMI rule. N equal to 1, P1 is true, and Pk true, then Pk plus 1 is true. So you try itself, only example 1 and example 3. And here one more sum, 10. Don't worry, I explain also next part, but you for self practice. Okay students? And here ending of this part. Thank you very much. Further explanation I explain in the next part.